Greetings, welcome to TFI. Anyone that asks, I use a 3D connection space mouse for making the camera move nice and fluidly. And also, if you're interested in seeing more from me, I do full, structured, proper, organised training courses over on the e-learning site, Plural site. If you want to head over for a free trial, my affiliate link, my referral link, is in the description of this video. Right, who knew? Who knew Inventor could do this? Look at that. It's not real cloth, it's not actual physics, but it's sort of simulating it. So if you want to know how to make Inventor do something like this, make an object move along what looks like cloth, I'm going to show you how to create this exact thing from start to finish in this tutorial. It's quite a high level tutorial, so a bit of prior knowledge of Inventor is required, I suppose. Right, okay, so here we go. So I'm going to start off by creating just an IPT, and we're going to start off by modeling a ball. Right, as you were seeing that object move along what was looking like a cloth, that was a ball-shaped object. So we're going to start with a 2D sketch on the XY plane, and we're going to knock up a circle. I'm using the proper units, which is millimeters. So we'll do something, say 50 mil in diameter. That'll do. The sizes actually don't matter at all in this instance, just for this tutorial. But I suppose if you're following to do something for your job, then sizes will matter, but in this pretendy example they don't. So I'm going to draw a line, and this is going to represent there'll be easier ways of doing this, but you know what, I don't care, this does the job. So this is going to be a center line, and it has to intersect the circle. Now the reason I'm not using an axis is because I need this to separate the circle into a semicircle. So I'm going to do a coincident constraint and then snap that line onto the center point, and that separates the circle into semicircles. Finish the sketch, and then we can revolve that half using the center line as an axis. There we go. Right, so there's our ball. Right, and that's what I'm going to use to move along an object. Now you can, if you want to, assign it material. It doesn't make any difference at all to the end result. But we can make this ABS plastic, and then you can give it a texture. But in my example, the ball's actually invisible, so it doesn't even matter. But if you want to give it a texture, you can do. Right, I'm going to save that, and I'm just going to drop it anywhere. It doesn't matter where you save it. In fact, for all intents and purposes, you can put it on your desktop if you want to, and then we can call this ball. But I'm not going to put it on my desktop, because if I do, it'll give us all kinds of messages about it not being in my active project. Right, these are the folders for my active project, and to avoid any dodgy messages, I'm not going to do that. So I'm just going to call this ball. And then what we're going to do next is start an assembly. Right, we're going to start a new standard.iam, and then we're going to place the ball. No, we're going to place the ball into the assembly. Right click, and then I'm going to ground at origin. Place and ground at origin, and press escape. So that puts the ball into the assembly, and it's now right smack bang in the middle of the assembly. Again, that is just purely for the purposes of this tutorial. If you're doing this in real life, you're going to need to place this in its appropriate position, not necessarily in the center of space, but I am for the tutorial. Next thing we're going to do is we're going to create a new part, but we're not going to make it separately as an IPT. We're going to create an in-place component. So this is what you would call top-down assembly leveling. You've got the assembly, and now you're creating the lower part level instance in the assembly. It's top-down modeling. So we're going to click create, and I'm going to call this I know it's not cloth, right? Calm down, just calm down. And it's not, but I'm going to model it so it kind of looks like cloth. So we're going to say cloth, and we're going to drop it in the same folder as the ball's at, and then click OK. And then it's asking me where I want to place the cloth, and I'm going to click the XY plane. Right, and then this bit is actually important, because we're going to need to use this XY plane a little bit later on. But hopefully, if you're following, it'll make sense why I'm doing this, so then you can use that in your example, in your work. So I'm going to click XY plane. And then the next thing I'm going to do is create a work plane. I'm going to expand the origin of my cloth part. Then I'm going to one left click on the XY plane, right? Then I'm going to move over, and then hold the left mouse button down in Inventor space, and then drag up. Right, so that gives me a work plane which is offset from this XY plane. And the reason why it was important that I used the XY plane for placing the cloth is that the XY plane for the cloth is now pretty much intersecting the center line of the ball. Right, so that just gives me, it just makes sure the XY plane isn't sort of shooting off here somewhere. Right, so this is going to be where the cloth lies. So if you see this line here, this is where the ball is going to protrude up the cloth. right? So however, I guess, high up you place this cloth is how much of a protrusion you're going to have up in the cloth. So I think we'll go for about 15 millimeters. That should be enough up out the cloth for it to kind of give a sizable dimple, if you know what I mean. And then we're going to click tick, and that's our work plane ready. Right, the work plane is purely there so we can now create a sketch to draw the boundary of the cloth. So I'm going to sketch on this XY plane, not the XY plane, sorry, the work plane. And then this is where we draw the cloth. Now, this can be any shape and size. It could be a square, it could be a circle, it could be anything. However, just so it sort of looks like cloth, I'm going to drop down line and I'm going to create an interpolation spline, and I'm going to make it relatively sizable. So let's just sort of give it a fair few edges, sort of like this. It's meant to simulate cloth, so I suppose that looks like a bit of a rag. As far as rags go, it looks pretty raggy to me. Finish the sketch, and then what we're going to do next is we're going to convert this into a boundary patch, right? And this is where we'll start to get into the high level stuff, right? A boundary patch is a surface. Don't worry about it, right? I'll do, if I haven't already done, I will do tutorials on each one of these individual features at some point in the future. But if you head on over to Pluralsight, I know I plugged this at the start, but Pluralsight do have full structured, organized classroom style courses on Inventor surface modeling, done by someone else, not me. I've done 2 courses so far on Pluralsight, but somebody has already done surface modeling using Inventor on Pluralsight. But we're going to hit patch, click this spline, and then click OK. Right, so that converts that spline into a thin-walled, essentially no-volume patch. And then we're going to use that as the cloth. Right, the next thing we're going to do is we're going to convert this boundary patch into a freeform solid. It's not a freeform solid, it's a freeform plane, I suppose, but it's not as solid as such. It's freeform, so it's given segments, it's given kind of like points and lines and edges that we can manipulate. And then the number of faces here on the length and the width is determining how many points and edges we've got to play with. So for example, if you were to say 20 and then 20, you get tons and tons and tons of edges to pull around, but I don't want too many, so I'm going to stick with 10 and 10. That should probably be enough. The more you give it, the more complex it's going to be and the more chance of failure is. But once you've finished this, you can play with it later on and then maybe just redo it if you want to see what's right for you. Right, and then I'm going to click OK. And that gives us our freeform. Now I'm going to come back and change this later on. Notice in the example that I played at the very start, I had like the cloth drooping over. So we can do that later on. We don't have to do that now. We can do that later on. Okay, so I'm going to click Finish the Freeform. And I'm going to turn off that work plane. So I'm going to right click on the work plane and turn its visibility off. And also the boundary patch, I'm going to turn its visibility off as well. So all we're left with is the ball, which isn't actually in this model. The ball is in the assembly. In the background, we're actually editing the cloth. You see the ball is part of the grayed out browser. So we're not editing the ball, but we can see it in the background. We're actually editing the cloth. And the only thing that's turned on is the freeform, which has now turned itself into an orange surface. And it's perfectly flat. That's fine. Okay, the next thing we're going to do is we're going to copy the ball into the cloth. Right, that might not make any sense whatsoever, but hopefully, again, once you see it happen, it will make sense. So we're going to drop down the Modify panel. This is Inventor 2018, by the way. So as Inventors moved throughout the years, they've moved things around. Copy object used to be up here, but now it's sort of down here. But it will be there. It's been in Inventor since around Inventor 2010, I want to say. I can't guarantee this will work on old versions of Inventor, but going back at least 3 or 4 years, you should be fine to do most of these things. So we're going to select copy object, and then I'm going to pick face, and I'm going to select the ball. And I'm going to make sure that this is really, really important. If you don't have this ticked, the entire thing will fail. So it needs to be associative, and it's going to be a surface. Right. What we're doing here is we're copying the face of the ball, which is another part. We're going to copy that face into this cloth part as an associative surface. So it's taken the ball, it's taken the face of the ball, and it's bringing it into our cloth assembly as a surface that's going to move wherever the ball goes. So it's like if you were to wrap a bit of cellophane or something around the ball, that's what it's putting into our cloth part. And wherever the ball goes, this bit of cellophane is going to move with it because it's associative. So we're going to click OK. So now, basically what happens now, if we right click on the ball and turn the ball assembly off, we're still left with that bit of cellophane, which is actually that surface there. That surface represents the face of the ball. Right, the next thing we're going to do is we're going to trim the ball using the cloth. Right, I'm going to refer to it as cloth. I know I've said it before, it's not cloth, but I'm going to just call it cloth because it's easier. You'll know what I mean if I say cloth. So we're going to use the cloth as the cutting tool, and then we're going to remove the bottom half of the ball. So that's sort of slicing away the bottom half of the surface of the ball using the cloth. And then, now this is where things start to get a little bit funky. We're going to do another trim. We're going to trim the cloth using the ball. So we're going to use that as the cutting tool, and then we're going to remove this sort of inner bit here. So we're now left with a dome of the ball on top of the cloth, but we've trimmed away the inside here. So if we were to turn off this surface, is that the surface that we want to turn off? I think so. Yeah, we should be left with a hole, right? So that's where the ball is. Hopefully you're following. If you're not following, it don't matter. It don't matter. Just do what I do, and it will work. It will work. Okay. The next thing I'm going to do. What am I going to do? What am I going to do? I think I'm going to go straight into... should we quilt this now or should we quilt it later? No, I tell you what we'll do now. We'll start making a bit of cloth, right? We'll do some exciting bits now. So we're going to double click form, right? This is the original bit of cloth that we converted into a freeform plane and give it lots of segments. And this is where we can start to make it look a little bit more like cloth. And the way we do this is we select edit form, pick an edge or a point, right? But I'm going to start with an edge. Right, or even a face, doesn't matter. And then grab one of these arrows and just pull it down like this. Click an edge, pull it down. Right, and this is where you start to make the surface droop and sag, and it makes it look like cloth. It doesn't make it cloth, but it makes it look like cloth. Then we can sort of, rotate things like this and pull it around, and it's up to you how much you do this. So we can maybe pull this bit, a little bit up, and then take this one here. I'm just picking this at complete random, sort of make that sag in the middle like that. Take this one here, pull it up. I genuinely picking these at complete random. If you do make things a bit too extreme, right, like pull it all the way down too much, then there is a chance that when it moves the ball across the cloth, it might not be able to solve it. So that's about. Here's another thing, a good thing you can do, right? Because at the moment we can't see the ball in the background. If you right click on the assembly node here and then turn on its visibility, that's where the ball is, that's where your surface is, and that's where your cutout is. So if you are pulling the cloth around, you can choose to either avoid that spot, or if you want to actually be brave and pull it around. But like I said, if you do make things a little bit too extreme, it might fail. It depends on how it solves it as it's moving across. But we'll cross that bridge when we come to it. Let's move that down a bit. It's looking kind of clothy in it. Let's grab this one here. Let's pull this one down a bit more there, and then we'll keep it at that. We'll not get too ambitious with it yet. So we'll finish that off, and then what we'll do now is we'll turn the ball back off, and then we're going to quilt this. What I mean by quilt it is we're going to turn the two surfaces, that one there and that one there, into a solid object. Alright, so that's going to represent, we're turning it into a solid bit of cloth. But before we quilt it, there's one more thing we need to do, and that's to stitch the two together. So we need to pick the surface of the cloth, the surface of the ball, and then hit apply. That stitches the two together. So now when we go for thicken and offset, we can go for the quilt option, pick the entire lot up, and then I'm going to quilt it by 0.5. That's already selected. It might say 1mm for you, but I'm going to quilt it by 0.5. Click OK, and that converts them both into a solid. That's a 0.5 mil thick solid, which kind of looks like a cloth, I suppose. You could make it a bit more clothy, but I'm happy with that for now. Right, you can see kind of bits of orange poking through. That's the leftover surfaces which have been used and created to form the quilt. I'm going to turn them off. You don't have to, but just for the purposes of my OCD, I like to turn them off so I don't see them. So right click on the surface and turn that off, and then the stitch, right click on that and then turn that off. Right, and then the final thing to do really is, the final bit of modeling is to give it a nice little fillet here, so it kind of shows the cloth rising up over the ball, and I'm just going to do that with a simple fillet. So we're going to select, make sure that there'll be a couple of edges in here. So I want to make sure I select the top one, and I'm going to select the smooth G2 fillet, which is more of an accurate it's more of an accurate transition, whereas a tangent fillet, it's very, very minimal, but it comes out of the cloth at a tangent. I don't want it to do that. I want it to come out perfectly smooth for when it does hit a dimple. And then for the radius, up to you. Let's try 10 mil radius. That might be fine. Okay, the bigger the radius, the more of a surface area it's going to have to solve, as it does move over dimples in this kind of pseudo cloth. So I'm going to leave it at 10 for now and click OK. And then there's your ball. That's the ball in the cloth. But how do we make it move? Right, well, what we've got to do next is return. All right, we're going to return up to the top level assembly, and then goddamn save it as fast as you can, because it might crash, and if it crashes, you have to do it all over again. So I'm going to call this ball and cloth, and then hit OK. And then to move the ball, well, when we placed the ball at the very start, we placed and grounded it at the origin, so it's got this little pin node over the node of the ball, which means the ball can't move. So if we switch on the visibility of the ball, hold the left mouse button down on and try and pull it, it ain't going to move, it's grounded. So we need to unground it by right-clicking on the node and then ungrounding it. Right, don't drag the ball. If you drag the ball, you're potentially going to pull it out from the cloth, and then it's going to try and solve this dimple. And if the ball's somewhere down here, it won't be able to solve the dimple, and it'll just fail, or you'll end up with some really strange result. The next thing we're going to do is we're going to constrain the ball in place. Right, so we're going to hit C on the keyboard to constrain, or I probably shouldn't use keyboard shortcuts in a tutorial. Hit constrain on the tutorial. Hit constrain on the ribbon bar at the top, and then we're going to constrain it in place without it moving. So we're going to expand the ball, and we're going to use its origin nodes. You don't have to. Again, if you're doing this in a proper example in a production assembly, you might not be able to use the origin nodes. As long as you understand what I'm trying to get at and what I'm doing, you hopefully will be able to transition that knowledge across to what it is you need to do with it. So I'm going to select the YZ plane of the ball, right, which is the center line going in that direction. And I'm going to constrain that to the YZ plane of the assembly, right, which is essentially in the same place as the ball. That should go clunk, and I'm going to flush it as well, not mate it. I want to flush it. Hit apply, and then the final constraint is going to be in the center line of the ball, the XY plane to the XY plane of the cloth. And I'm just going to flush that as well. Hit apply. Right, that's it. The final thing that we need to do is to animate it. And to animate it, we're going to drive the constraint, and that's going to be the first one here. Because I constrained it across the YZ plane, it's going to move normal to that plane, so it's going to move that direction. If we constrained that plane there, not that plane there, there'll be that one there. If we use the XZ plane, the ball would move in that direction. So again, it depends what you want to do. You don't even have to use the origin planes. You could create your own work planes, and then you can move it at a distance or a direction of your choosing. In fact, once this is finished, you could even constrain it to a path and have it moving around a path if you wanted to, but keep things as simple as I can in these sort of tutorials. I don't want to get too fancy. So for the flush assembly, for the flush constraint, that's actually going to be the one that drives the motion. I'm going to rename this to motion, right click on it, and then select drive. Right, so at the moment the constraint is 0 millimeters, right? It's in place. It is where it is. That's 0. And then the end is going to be how far you want to drive this. So I'm going to let's start with 30 millimeters, and then the next thing to do is to expand more, and you've got to select drive adaptivity or it won't work. Hit play, and then there's your ball moving. Now it will move very, very, very slow, because as it's moving, it's got a lot to compute. It's got a lot of things that it's got to solve. Every time the ball moves, it's moving in 1 millimeter increments. It's got to solve, can the fillet work? Where's the surface when the ball moves? It's got to solve that in accordance to the pseudo cloth, and then it's got to do it again and again and again and again. So it's got a lot to compute. So it might take a little bit of time to do that. But there you go. That's it moving. If you want to look at it in a bit more detail, so it looks a little bit more realistic, you can start to play around with the visualizations and the materials and the textures. So the next thing I would normally do is turn the shadows on. So I'm going to select this bottom face here and look side on. I'm going to right click on the cube and then set that as front. You can't see that, it's gone off the screen, but right click on the cube, set current view as front, and that should set that view as the front. If you don't need to see the ball, you can actually turn the ball off and it won't make any difference. But you can turn the ball visibility off and it will look like there's just a dimple moving over the cloth. But that again depends on what you're trying to get out of this. So we're going to hit view. We're going to go to the visual style and make this realistic. And then we're going to drop down the shadow drop down, turn on all shadows. Let's change this to grid light, so it just brightens the scene up a little bit, and then change this to perspective view. We should now have what looks like a dimple in a bit of cloth. It's not massively realistic, but that will depend on where your dimples are in your cloth, I suppose. And then we can double click the cloth. All right, make sure you're editing that, and then you can assign it a material. A good material to choose for cloth would be to use the Autodesk Appearance Library, and then go for one of the linen materials, like linen. I don't know why there's two linen whites, but something like that. The texture is a bit too big for this, so let's hit this little browser button there. Right click on the material, edit that, hit the swatch. And let's reduce the sample size. This is the size of the bitmap that it puts against the material. So let's change this down to, say, 6 centimeters by 6. Okay, it's got to keep the aspect ratio. That's fine. Shut that down. Hit apply. Cancel. Shut that down. And for some bizarre reason, it doesn't actually update it until you move. I don't know why. I don't know why it does that. It's just one of those Inventor Autodesk-isms. And there you go. There you go. Right, let's try driving the constraint again and see what happens. So we'll go to motion, right click and drive. We'll start at 0, end it. Let's go the other way. Let's go -30 and then hit play. And then it's now going in that direction. And that's how you do it. That is how you do it. If you want to see the ball at different positions on the cloth, you can just edit the start position of the motion constraint. So at the moment we're at 0, but if you just change that explicitly to be, say, -50, for example, that'll move it there. Let's try -100. It will, or it might, I can't say definitely, but it might get to a point where it just can't solve it anymore. It depends how far along it is. But let's try 190. So we're kind of hanging off. There we are. So we're now kind of off the edge of the cloth there. So you can see the fillets are still solving. It's still doing a pretty good job. But if you want to change the way the cloth hangs, you would just edit the cloth part, double click the form, and then turn on the ball. And then that'll show you where it is. Just turn on the visibility of the ball so you can see that's where the ball is now in relation to the form. So we can now take these points, edit those, and then we can just drag it around, or I don't know, do whatever you need to do. You can use all of the freeform solid editing options to play around with the cloth. You can scale, rotate, push, pull, do whatever you want with all these points. But let's take a whole face and move that up a little bit. But if you do move it too far up, like for example, if that was to move there, that ball will it'll be under the cloth, so that just wouldn't work. It would probably give you an error at that point. The same goes if you move this too far down, the ball would be completely, above the cloth, and again, that just wouldn't work. The fillet wouldn't be able to solve. So you do have to be a bit careful with it. It's not completely foolproof. But then that's what happens when it can't solve it. It'll say errors occurred during update, and then something will break, whether it be a surface or the fillet. But essentially, that's how you do it. So I'm just going to undo that last change because I don't want to leave it broken. Finish the freeform. There we go. Right, so at the very start of the video, I showed you a video file playing. It animated as it's, it was a WMV file. To do that, you go into Inventor Studio. So we're going to just finish up by showing you how to do that. Let's go to the Environments tab, Inventor Studio. And we're going to create a very quick animation. So hit the animation timeline. OK on that, and then we're going to select this button down here, which is the animation options. This is where you tell it how long the animation is going to be. This is not an Inventor Studio tutorial, so I'm going to sort of blitz through this. So we're going to have 10 seconds worth of animation. Hit OK, and then we are going to is the constraint there, right? So that's the constraint we want to animate. So we're going to select Animate Constraints. We're going to select the motion constraint. We want it to start at 190, where it is now, and we want it to end at 0. And we're going to start that motion at nothing, and end at 10 seconds. And then click OK. So over the 10 seconds, it's going to move from there to there. And you can sort of use the play buttons on here to see that happening. So that's it in reverse. It's going to go back. And you can see the cloth sort of moving around the ball. It's pretty good, actually. It's doing a pretty good job of it for what's not actually even a cloth. It looks all right. And then if you use a bigger ball, you'll get a bigger fillet. You'll get maybe a more realistic effect. Also, when you're doing your freeform, if you put more segments in, then there's more area and more dimples, kind of more condensed for the cloth to wave around a bit more. So that would be a thing for you to play with if you want to. And you will need a pretty powerful computer to do this. Mine's an i7 4790K. It's quite an old i7 now, but it's pretty powerful. Anyone on old hardware, you might struggle at this point when you're animating the movement. But once you've got that set up, the next thing you would do is you'd select Render Animation, go to Output. The bigger the resolution you use, obviously, the longer it's going to take to animate. But use something like 1024 by 768, just smallish resolution, just to make sure that it's actually going to work and it's not going to fail and look stupid. And just in the interests of simplicity, I'm going to keep the camera as is, the lighting style as is. For the output, I'm going to select WMV. Do not select AVI. At the moment, the way Inventor is right now, if you select AVI, it doesn't matter what you do, Inventor will crash when you try and render it out. So we're going to select WMV. Yes, to that. We're going to render 10 seconds because that's pretty much all there is. You can select this here, just the entire animation. It'll detect that it's a 10-second timeline. But you can pick and choose how much of the 10 seconds to animate. If you just want to animate 5 seconds, you can say just render 0 to 5 seconds. Right, for frame rate, I prefer to always go to 60, but bear in mind that the Inventor Studio animation is pretty much a whole bunch of pictures strung together to make a video. So if you've got 60 frames per second, it's got to render 60 frames for every 1 second of video. So for example, if you were to go for 10 seconds, then that's 600 frames that it has to render, which just takes longer. It'll look better, but it'll just take longer. Right, and then you'll go, best to just have no render. Again, it makes it a little bit quicker. For the renderer, it's a ray traced render, so however many iterations per frame, again, it takes longer. 32 is the default, so it's got to do 32 ray trace passes per frame for each of the 600 frames, so it might take a while to do. And then you just click go, confirms the settings, and then away you go. And then that'll take however long it takes. You can see it's going up pretty slowly, but that's how you render it out for an Inventor Studio video. I would never do a video like this, an Inventor Studio video like this for anything in production. I would need to put on lights, a better background, make it look better than it is right now. The whole point of doing it this way is just proof of concept that it is actually going to work. It's going to be smooth, it's not jerky, that kind of thing. That would be the point of this one. So I'm just going to stop it there, because I'm not going to wait until it's completely finished. And then I'm going to head over to my desktop. There it is, ball and cloth. So, yeah, it did about a second of it. And it's too blocky and pixelated. But that's the WMV quality. But anyway, that's how you do it. That's how you do it. And that's how you get a ball underneath a bit of pseudo cloth. Move it using animation. Right, thanks very much, guys. I'm going to knock it on the head there. That's all there is to it. You can now take that and you can tweak it to your heart's content. Different sized cloth, different shaped object. Doesn't have to be a ball either. You can use any shaped object you want, but that might make the fillet at the bottom a little bit more difficult. That's when you would have to start getting a bit more creative and experimenting a bit more with problem solving. So as I said at the start of the video, if you want to see more courses from me, I've got 2 full structured classroom style organized courses over on Pluralsight. If you want to check out the link in the description of this video, that's my referral link if you want to go and start a free trial with them. Alright guys, thanks very much, and I'll see you in the next one. Toodles.